So let's go ahead and take a look at one of many solutions to our last activity, in which our mission was to scan every file in the present working directory, listing handy classes found in the Python files. Deceptively easy to do, and we should probably do it stage by stage. And the first thing we want to do is create a function to list the files in a directory. Now let's use my German notation. Put that in quotations for German. And then you use a Python variable definition to mix it up a bit. And we'll say it's going to be o.y. Great. So our input's very well defined. We're going to be looking into the directory for a file type that has a suffix of pi. You might even want to spell it right. So we're going to need the OS module to do this, I would think. So let's go ahead and import OS module. And then we're going to want to have some results. And we'll make that a list because lists are mutable. Of course, we could also square braces if we wanted to. And now let's go ahead and get each one of our files in the os.lister, which we'll use, of course, as the directory. And for each one of those files, if we have one, of course, we're going to have to see if the file, and just for the fish or the halibut, that's a string, so we can use ends with our file type. And we have a good candidate for what we want to check. That's, of course, going to be a Python file. So let's set a zip file equal to zip. And probably let's go with plus. Should we hard code that or not? Let's just go ahead and use Python's default for the path. We could use the OS separator, of course, for each character plus the file. And of course, all we have to do, darling, is then take results, append the old Z file. That should work pretty well. So now let's try a little test case. If dunder name equals dunder main, in other words, if we're running as the main module, then let's go ahead and, I want to know at first blush, I suppose we should check to see if this puppy works. And since we did say we wanted the present working directory, I've saved this out in my study, as you can tell up here. So probably the PWD was meant to be the whole path to my StarTrek information. We've got a problem here because we're now using Microsoft's \, which is going to simply escape the U, escape the R, escape the T, etc. So we'll just make that string literal by using R. And then we can say, ladies and gentlemen, do not expand the backslashes for \T or \N or anything we get up here. And instead use a literal \. Yeah, I've been correcting these backslashes for decades, from Java to C to C++. Honestly, it really makes you wonder why Microsoft just didn't do it the way everybody else is doing it. Not only because it's convention today, but they knew what they were doing. That Linux had /, but it decided to use backslashes for, in my opinion, completely egocentrical reasons. Whatever, I rant. But really, how many people have been messing around because Mr. Oh No Gates wanted to do everything from C# rather than C++, to have his own idiotic file system, which was a personal file system. It just doesn't even work in a multi-user world, in my arrogant opinion. Over the decades, I've been offered several jobs at Microsoft. I've turned them down just on principle. And I'm living poorly because of my integrity. But that's another story. Okay, so let's go ahead and call our function list files for our PWD. I'm very lucky I saved you a rant because other people have enjoyed it. Put enjoy in quotes. And the Z blocks, for example, of course, is going to be returned. So let's just go ahead and see if things work by printing FSS with a mump and zip file. That should work out okie dokies. Let's run it and see how it does. No bad, no bad. We see all of our very interesting information and gosh. Once again, that rant is aborted because you just heard it, but we get 21 files, and these are the files we see, of course, in our PyTrack deck. Let's go ahead and import os.path.sep. It'll change for one for POSIX-inspired operating systems and the other one for MS-DOS. Very good. Certainly very consistent. And of course, like Java, Python, of course, does indeed navigate between forward slashes and backslashes for us, which I find very wonderful, because we'll be using the forward slash for POSIX-inspired version later on for your listening and hacking enjoyment. So if you haven't already done so, go ahead and create this file. You can call it listclasses.py or anything else you want. And I'll even go ahead and put in the ready moniker. Say we're not set or we're not coding, not officially, so as to keep in with our RSC moniker and keep the documentation succinct for our use. Speaking of documentation, let's go ahead and add a doc string for the thing. We now have our first class function because, of course, we can now execute the help system to see our doc string on our command line interface. Very Pythonic. Now, the question occurs now, is this a very good way to detect changes or regressions in our system? In other words, can this become one of our test cases? Well, I'm going to say no, simply because I'm in the ready stage. I'm not in the code stage. If I was in the code stage, I might go ahead and create a folder full of a bunch of types, and I'd put that somewhere else, perhaps in my test server or on a test path on my operating system, and I would create that set of files, put all the information there I needed to verify, and then run our test cases well beyond what we want to do now that we're on the ready state. But I do want to keep it laying around. So I'm going to go ahead and call this list case 001. We should have more than 100 or so of these before I go ahead to change what we've done by now, rather than showing everything else nice and pretty. Let's go ahead and write a function that will list any blocks, in this case class definitions, we find in our file. So for lack of a better, we simply call our new function list. And I suppose what I'd like to have in list blocks would probably be the name of the file. And then whatever I want to find in the block. In this case, we'll make it the class string. And we should probably return a list, so I could say for block in list file blocks. And we take a path to the definition. So writing list blocks, the Python file, and let's go ahead and call the next one a gatekeeper. That's kind of what it is. And let's take a pass at this, because you know what really makes sense at this point in time would be to add in some data types. And what I mean by data types, well, if you're an accomplished Pythoneer, forgive the vector. Let's go ahead and import to discover we've got a huge amount of information, but we're probably going to be very interested in our list type, which is, as the name implies, an instance of a list class. And probably, I don't know, let's say we'll probably need a text one, I would think. We'll see that it aliases over to being a string, which is exactly what we want. And if we took help now on typing .list, we're simply going to have a generic version of list. In other words, it's going to be something that many different list types can use, which will have all the members we need, certainly enough to import. Typing, so as to say that this is going to be taking the Py file is going to be a text, and the gatekeeper is going to be a list. And now we're going to probably want to return a list. Now, this type pending is kind of fun. It's a new standard, and it's there for IDEs and do a lot more than what we're used to having our IDEs doing. But since we know we're going to return a list, let's go ahead and return that now before trying our block. Now, of course, the reason why we have to try is because we're going to be working with the file system. And if things go bad, of course, like if the file gets deleted or we don't have access to it or any one of 100 other reasons, maybe only 27, we're going to print that error out so that we can see what happened. So, with open the Python file, there had to be in the PWD or fully qualified. And let's add as my favorite file handle. It shows my Linux upbringing. We check for each line, a new line separated definition, and the file handle. And with that new line, we'll look for an integer position of the line, find our gatekeeper. Now, if pos does not equal -1, in other words, we've found what we're looking for, then we're going to want to have this string, pardon my nail channel, and let's go from the position it was found to the end, grab the rest of the line, and now we want to find the closing definition, where this time pos is going to equal this stir, find, and we're going to want to simply have a colon, because all our blocks are kept by gates of very great colonnates. And here again, if pos is not found, then we're going to want to do the same thing, only a little different. The stir is going to equal the substring of itself from the 0th position to the pos. And since we're going to get the pos -1, in other words, we're going to get everything just before the colon. If we wanted to get the colon, of course, we'd simply add 1. But now, of course, we simply want the class definition, not anything more, before we actually collect our result into our results collections. So let's print our file separately before the clutter begins. Much easier to read. Commenting out a file, of course. The game pieces are pretty unique in the game. And we see we've got a lot of definitions in addition to the parentage that we could probably do a nice little graphical user interface for. Simply to check if everything works the way it should. One of our requirements, of course, was to sort the information in our blocks. So rather than print everything, let's make a report and append everything that comes from that into the report before enumerating our report out from our sorted report file. Totally alphabetized.